Okay, I'm gonna attempt to knock one more out here. And that's information to do with light. So the speed of light is 3 times 10 to the 8th, 67 million miles an hour. Quite a bit faster than sound. Uh, light can reflect like mirrors or refract like lenses when it comes in contact with different optics. Um, Two types of mirrors are concave, and that would have a positive focal, and convex, that has a negative focal. Two types of lenses are converging and diverging. Diverging is negative, converging is positive. Um, Light waves are always transverse, so they go up and down like all electromagnetic radiation. Curvature of radius is 2 times the focal, r equals 2f. Magnification equals hi over ho, negative di over do. Lens makers 1 over f equals 1 over di plus 1 over do. Two examples here. We'll do our ray trace first. Come in parallel. This is a mirror, so we're going to bounce off. It's convex, so we bounce off like this. Hit the only flat part of the mirror and leave it at an equal angle, and then we try to get to the focal and we can't. We go back. Ooh, that's not flat at all. Sorry, ignore that. And so then we just kind of dot our lines back, and we can see that it's going to be a virtual erect reduced image. If we want to find all our stuff, probably better just to do the math. Was the focal given? Focal 4. Alright, so negative 4. 1 over f equals 1 over di plus 1 over do. So I have 1 over negative 4 equals 1 over di plus 1 over do is 1/3. The obvious common denominator is 12, so we get negative 3/12 equals 1 over di plus 4/12. So we get negative 7/12 equals 1 over di, or di equals negative 12/7. So di is 1.71, negative 1.7. So that's my distance to the image is negative 1.7. Once I know what di is, it should be di on the study guide. Once I know what di is, I can then solve for things like magnification. So magnification is negative di over do. So I have negative of a negative, making it positive, positive 1.7, over the distance to the object, which was 3, something around a half. We'll see what it is. 1.7 divided by 3 is 0.56. So we'll say 0.57 for magnification. And it's positive, meaning that it's erect, but it's less than 1, meaning it's reduced. Hi, so 0.57 equals negative di over do, but it also equals hi over ho. So we put in the height of the object, which was given 4. 4 times 0.57, 2.27 for the height of the image. Let's try a lens out here. This is a converging lens. So the rays come in parallel, driven to the focal, to the origin, keep on going. And we go down based on the focal that's over here, and then we leave parallel, and you can see our image will be over there like that. That's our image. So we can do some math now. Focal's still 4, it's positive 4 because, it's converging. Distance to the image is what we'd like to find. DO 6, 24, so 6/24 and 4/24. So we subtract minus 2/24 or di equals 12. Once again, I messed this up. It should be di is 12. Once we know what di is, then we can solve for magnification. Magnification can be found by saying negative di over do. So we have negative 12 over the distance to the object, which was given 6. So we get negative 2. But, yeah, negative 2. Put that in there for magnification. And then we have to solve for the last thing, which is the height of the image. So magnification also equals hi over ho. Put in the height of my object, which was 4. 4 times negative 2 is negative 8. So that's the height of the object, negative 8. Or image, sorry, height of image, negative 8. Okay, that's it for Lens and Mirrors. 6 minutes, new record.